Good morning, students of grade 8. Today we are going to continue through our lesson pressure, and up to our previous class we have taken combined class. We take your combined class along with grade 10. Okay, now we are separating our classes. Today your topic is atmospheric pressure. We'll discuss in briefly about atmospheric pressure, and then we'll go to density and relative density. Okay, now I'll start from atmosphere. What do you mean by atmosphere? Atmosphere means the layer of air surrounding the earth. Yes, wait. The layer of air surrounding the earth is called atmosphere. And why do atmosphere cover the earth? If you know that, definitely why do atmosphere layer of air or atmosphere cover the earth? It is because of gravity. Yes, because of gravity, air molecules are being pulled toward the center of earth. That means air also has weight. Okay, that means air also has weight. Definitely, if it has weight, weight also means force, isn't it? Definitely it is force of gravity. Okay, amount of force of gravity, but it is also force. That means air applies force, or you can call it thrust, because as the air is being attracted towards center of earth, the force applied by air is always acted perpendicularly on the ground. Okay, the force applied by air always acts perpendicularly on the ground. That is because of gravity. So it is also referred as thrust. Okay, now air also applies thrust on the ground. Yes, air applies thrust on the ground, and if you take thrust per unit area, then that is called atmospheric pressure. Okay, very simple. The concept is very simple. Atmosphere means the layer of air surrounding the earth. Okay, and the layer of air or air surrounds the earth because of gravity. Okay, and that is why air also has weight, and because of same gravity, the force or the weight of air exert the force on the ground perpendicularly. Okay, the weight of air exert force on the ground perpendicularly, and that force applied perpendicularly on the ground is called thrust. If we take thrust per unit area, then it is called atmospheric pressure. Okay, so you can define atmospheric pressure as atmospheric pressure is defined as thrust applied by the atmosphere per unit surface area on the ground. Yes, it is due to the gravity or weight. Okay, atmospheric pressure is defined as thrust applied by atmosphere per unit surface area on the ground. It is due to gravity/weight. And you all know what device. Okay, before that, let's go to some explanations. What is the proof that atmosphere exert pressure? Or verification. What verifies atmospheric pressure? Now this one experiment you have to perform. I'm just going to tell you what you need to do. Okay, but you have to perform on your own. Okay, let me use another paper. Once again, I am not going to perform it. I'm just going to tell you how to perform it. Okay, I'm just going to tell you what to do, how to do. You have to perform it on your own. Okay, first activity number 1. This is quite dangerous activity, not so dangerous, but you need to be a lot careful. Okay, what we are going to do is to prove atmospheric pressure. Okay, this is our objective. Okay, this is our objective and title of experiment. And what materials do we require? Materials needed. Okay, if you can gather these materials, a tin can with lid. Okay. This is quite difficult to obtain nowadays, because in past most of the food items come in tin can, but nowadays they mostly come in plastic bottles. Okay, like if you do you remember some products like Cerelac, Lactogen, and several other products which comes in tin can, or in common language we call it Golden. Yes. Okay, these tin cans have a cover here, okay, which can be opened by using a screwdriver. But you do not need to use screwdriver in its exact way. You need to use it as a lever. Okay, by using a lever you can open up this cover. Okay, this type of tin can we need for this experiment. Okay, but availability of such tin can is very rare nowadays, because I've already told you most of the food items nowadays do not come in such tin can. They come either in plastic bottle or they come in carton box and etc. Okay, so this is quite rare. And then after you need stove, or in case of in home you can do it in stove, but in case of lab you need Bunsen burner. Okay, Bunsen burner is a special kind of burner which is used in science lab. And then you need water. Okay, if you can collect this much of material, then you can perform this experiment. And procedure, what to do, let me tell you the procedure, then you have to perform. In step 1, what we do, you take a tin can. Okay, you take a tin can and fill it with water, only half or less than half. Okay, fill it with water less than half. Keep its lid open. Do not close its lid. Keep its lid open. Okay, and then after you heat it. Okay, you put it on the stove. And remember, this is going to be very hot. That's why you need to be careful. This is going to be very hot. This is a metal can, yes, and it is good conductor of heat. Okay, you need to be very careful. Okay, and wait for evaporation. Okay, let it evaporate. And while evaporating, while heating, what happens is that because of heat energy, the air inside can becomes hot as well. And you know, hot air always moves in upward direction. Yes, hot air moves up in upward direction. Moreover, when water starts to evaporate, this space is occupied by water vapor. Okay, make sure that all air particles is out of the tin can. And the space inside tin can is completely occupied by water vapor. And how can you be so sure about it? Wait until water decreases by some amount, at least by half amount. When water decreases by 50%, then you can be sure that the chamber, the space inside the tin can is completely filled with water vapor. Then after, you take it out from the fire by using safety measures. Okay, do not catch it with your bare hands. By using safety measure, you take it out from the fire. Okay, and then place the lid. cover it up, place the lid. Okay, the lid must be airtight. Cover it up with lid. The lid must be airtight so that the water vapor in this space is trapped inside and air from outside is not allowed to get inside. Okay, and then after, what you do, you pour some water. You pour some water, cold water, over here, over the can. Okay, what happens by doing so? By cooling, the water vapor condenses back to liquid. Yes, water vapor condenses back to liquid. And when water vapor condenses back to liquid, this space, it becomes vacuum. Isn't it? This space becomes vacuum because there is obviously no air molecule. There was only water vapor. Okay, water molecule in vapor phase, and when this water molecule condenses back to liquid form, this space, it will have nothing, and because of that, internally it has no pressure, but externally the air is applying pressure. Yes, externally air is applying pressure, but internally it has no pressure. So to balance that pressure, what happens? The tin can, it collapses like this. The tin can collapses because of the external atmospheric pressure. Understood? I guess you can do it quite easily, but the only problem, I can also show it. I can also do it and show it, but the only problem is here, the material, tin can with lid. It is quite it is not so easy to obtain. Yes. Okay, if you can get this material, get the tin can with lid, then you can contact me when our school reopens, and then I can show you doing this experiment in our school. Okay. Now write it down. In doing experiment, making report of experiment, remember you need to draw a diagram as well. Now the procedure, in step 1, what we did, water was filled in tin can up to half. Then keeping the lid open, the can was heated. Number 3, as water started to vaporize and about 50% of water is evaporated, it was taken out of fire. And then what did we do? The tin can was closed with a lid. It must be airtight. And then cold water was poured over it. And what is our observation? By doing so, what do we observe? Observation. As cold water was poured, the can collapsed inward. Okay, and now we are going to write inference. We need to copy up to here. I'm going to change paper. Okay, freeze your screen and then copy it. Okay, you do not need to copy this much. Okay, this much you do not need to copy. This much, okay, you do not need to copy. Activity, materials needed, procedure, and this diagram. Okay, step-by-step diagram, and then the procedure, and then observation. Okay, I'm going to change paper. We are going to write inference. Inference means explanation of theoretical ground on which we can explain the observation. Okay, why did we observe that? What is the scientific or theoretical basis, ground, scientific basis of the observation? Okay, when heating, air inside the can becomes lighter and move upward. The space in the can is occupied. Okay, I'm writing the same thing that I explained earlier. Okay, it's not anything new. Is occupied by water vapor. Okay, the space in the can is occupied by water vapor. Then when cold water is poured, the vapor condenses and forms back to water. So the space in the tin becomes vacuum. Hence, there is no pressure from inside, but atmosphere exert pressure from outside due to this imbalance in pressure. The tin can collapses. Okay, now conclusion. Is atmosphere exert pressure. Okay, this much. Okay, make note of it. Okay, next title. What do we devise to measure atmospheric pressure? Device to measure atmospheric pressure. What device do we use to measure atmospheric pressure? And you quite know it very well. It's called mercury barometer. Yes, mercury barometer. And how does mercury barometer measures atmospheric pressure? Is, look here, you take a trough, a glass trough. Okay, trough means a simple container having wide mouth. Okay, in common language we call it bata. Yes, okay. A trough, glass trough is taken and it is filled with mercury. What is it? What? It is mercury. It's filled with mercury. Okay. Then after, a tube over 1 meter length. Okay. A tube having 1 meter length is taken which have markings. Okay. Which have markings in reverse manner. Which have reverse marking. Reverse marking means this be 100 centimeter, 90 centimeter, 80 centimeter, 70 centimeter, 60 centimeter, 50 centimeter, 40, 30, 20, 10, 0, which have reverse marking, and the level 0 must be dipped on up to the mercuric level. That must be kept in mind. Okay, A tube of up to 1 meter length is taken, which have reverse marking, okay, and it is filled completely with mercury. It is also completely filled with mercury, and then the mouth of the tube is covered. Okay, it is made airtight. The mouth of tube is covered, and then it is inverted. Okay, inverted, and it is kept inside the mercury, okay, by using a beehive shelf. You know beehive shelf? Okay, beehive shelf has a little hole over here and here over here, so that it can support the test tube. Okay, at the same time it allows the materials to flow through in and out of the test tube. It forms a communication system. If you do not keep beehive shelf and simply you rest the tube on the bottom of trough, then mercury from inside cannot flow outside, and you cannot measure air pressure with that. Okay, so you invert it. Okay, so it must be, you must be careful that the zero level of tube must touch the level of mercury in trough. 100 is here. Okay, it is somewhat like this. Okay, okay. Now what happens? It is completely filled with mercury. Yes. Now here, this surface of mercury, please listen carefully. This surface of mercury and this surface of mercury, they are in constant communication through the whole of beehive cells. Beehive cell. Okay, they are in continuous communication with the whole of beehive cell. That means if there is imbalance of pressure between this surface and this surface, then mercury can flow in and out to balance that pressure. Okay, and mercury or any liquid always flows from high pressure to low pressure. Okay, if pressure is high outside, then the mercury will flow inside. If pressure is high inside, then the mercury will flow outside, and the flow of mercury will stop exactly when the pressure becomes equal in inside and outside. Now see, outside surface of mercury experiences pressure from atmosphere. Yes, atmosphere exert pressure on outside surface of mercury. Okay, but inside surface of mercury, it is not exposed to atmosphere, but this column of mercury exert pressure on inside surface. The column of mercury exert pressure on inside surface. Okay, so the mercury exert pressure here, mercuric pressure. Okay, now what happens? The pressure exerted by mercury and atmosphere, they are not equal. Definitely they are not equal, and it is observed that mercuric pressure is higher than atmospheric pressure. In that case, what happens? Mercury will flow out of the tube. Mercury starts to flow out of the tube, so the level of mercury falls down. Okay, it keeps on falling until pressure inside and outside becomes equal. Okay, when the pressure becomes equal, it stops flowing. Okay, so when the experiment was conducted in sea level, it stopped at 76 centimeter. Okay, that means 760 millimeter. Okay, the value is not same for all places. Okay, if you take it to a place where atmospheric pressure is lower, then the mercuric level will drop even more. Okay, if you take it to the place where pressure is more, then the mercuric level will rise up. Okay, so when this experiment conducted at sea level, then the mercury stops flowing at 76 centimeter. That means 760 millimeter. Okay, what does it signify? It signifies that 760 millimeter of mercury, Hg is symbol of mercury, scientific symbol of mercury. Yes, so 760 millimeter of mercury exert same amount of pressure, same amount of pressure as the atmosphere. Okay, it is simply a comparison of atmospheric pressure. It compares atmospheric pressure to pressure exerted by mercury, and it says pressure exerted by 760 millimeter of mercury column is same as atmospheric pressure. Okay, or same as amount of pressure exerted by atmosphere. That is why we tend to write atmospheric pressure is 760 mmHg. Okay, now remember, this is not actual unit of pressure. Okay, not the unit of pressure. Don't be confused. Okay, mmHg is not the unit of pressure. It is simply a comparison. Okay, and this is also referred as 1 bar. Okay, I guess ink finished. Let me change the refill. Okay, this is also referred as 1 bar pressure. 1 bar means pressure exerted by atmosphere. Okay, I hope you understand up to here. Now what we are going to do is we are going to convert this 760 mmHg into actual unit of pressure. Okay, the title is convert 1 atm into SI unit. Okay, as we know, 1 atm means what? 1 atm is equals to 760 mmHg. Okay, now once again remember, mmHg is not the unit of pressure. Okay, it simply means height of mercury column. It means only this much. It gives us only this one information, 760 mm, which means 760 divided by 1000 meter gives 0.76 meter. Height of mercury column is 0.76 meter. We are given only this much amount of information. Yes, and then after you know, mercury is liquid, isn't it? So you need to use the formula of liquid pressure, that is P equals to SdG. Mercury is liquid, and how much pressure is exerted by liquid? To calculate that, we need this formula P equals to H into D into G. You have the value of H, now you need the value of D, and it's density of mercury. Density of mercury D is equals to 13,600 kg per meter cube, and you need value of G, that is acceleration due to gravity. Acceleration due to gravity, G equals to, it is 9.8 meter per second square. Now P equals to dGh. D 13,600 into G 9.8 into H 0.76. Now what will it give us? Let me calculate it. 0.76 into 9.8. 8 6 48. 8 7 56 plus 4 60. Okay, 9 6 54. 9 7 63 and 5 68. 8 4 12 14 7 and decimal 3 digit 1 2 3 7.448. 13,600 into 7.448. Now there are 2 zeros, and here after decimal there are 3 digit. Okay, that means these 2 zeros will cancel out, will shift the decimal by 2 digit. Yes, so we get 136, okay, 744.8 into 136. We get this. Okay, 6 8 48, 6 4 24 or 28, 6 4 24 to 26, 6 7 42 44, 3 8 24, 2 3 4 12 to 14, 3 4 12 1 13, and 3 7 21 1 22, 8 4 4 7. Let add it up. 8 8 4 12 1 carry 1 10 18 19 carry over 1 4 12 carry over 1 8 10 11 carry over 1 9 10. Okay, decimal 1 digit. Okay, it gives us 101,292.8 Pascal. Okay, in scientific system it can also be written as 1.01 into 10 to the power 1 2 3 4 5 10 to the power 5 Pascal. Okay, so 1 atmospheric pressure, okay, 1 atmospheric pressure is equals to, therefore 1 atm, that means 760 mmHg is equals to 1.01 into 10 to the power 5 Pascal. So in SI system, actually speaking, in SI system, the atmospheric pressure is 1.01 into 10 to the power 5 Pascal. Okay, 760 mmHg is just a comparative term. Okay, discussing this much, now we are going to discuss some features of features means effects of atmospheric pressure. Okay, effects of atmospheric pressure. Okay, one of the common effects that is seen is when we ascend. Okay, when we ascend to high altitude, we feel headache, vomiting, or headache, vomiting slash nausea. Nausea is a feeling of like vomiting. Okay, you feel like you want to vomit, but actually there is no vomiting. Okay, vomiting, nausea, and then after nose bleeding, etc. This is a common effect due to atmospheric pressure. When we ascend to high altitude, like climbing a mountain or getting to the top of a hill, also called Deurali, okay, getting to such places, we feel headache. Okay, we feel like vomiting, or sometimes we vomit as well, and there is nose bleeding, and some even feel like diarrhea. Some even suffer from diarrhea. Why does this symptom occur? What is the reason behind them? Actually, this is your question for today. Okay, this is your homework. Why? Now, let me explain it. You write it on your own. As we move to higher altitude, atmospheric pressure drops. Okay, because you see, this is the atmosphere. Then you can see as you move up, height of atmospheric column, air column decreases, isn't it? Height of air column decreases. Okay, and you know P is proportional to H. As height of air column decreases, pressure also decreases. So as you move upward, atmospheric pressure decreases. But the inside your body, several fluids are there. Okay, several fluids are present in your body, like your blood. Okay, blood or interstitial fluid or cytoplasm. Okay, there are several different kinds of fluid in your body which also exert pressure. These fluids inside our body, they exert pressure from inside. Okay, and atmosphere exert pressure from outside. Suppose this is your body has blood and fluid. Okay, they exert pressure in outward direction from inside, and atmosphere exert in inward direction from outside. Okay, and due to the balance of these two pressure, your body is stabilized. But as you move to higher altitude, then atmospheric pressure decreases, but the pressure inside your body remains the same. Okay, so your body will experience a condition like high blood pressure. Okay, it seems like blood pressure is rising, and because of that pressure, you feel headache, Okay, because blood is giving more pressure from inside, you feel headache, and to release the pressure from inside your body wants to release some amount of water. Okay, your body wants to get some amount of water out of your body, and that is in the form of vomiting. If there is anything in your stomach, your body wants to throw it out. And in some cases, even blood is released from weak vessels, okay, weak capillaries, and the weakest capillaries lie inside our nose, and so these capillaries burst and blood flows outward. Or in some cases you even feel diarrhea. Diarrhea is also an attempt to get rid of water from your body. Okay, this is all to balance the pressure between your body and atmosphere. Okay. Okay, now next effect of atmosphere is filling ink in fountain pen. Okay, filling ink in fountain pen. Okay, what happens in fountain pen is, suppose this is surface of ink and the entire surface is under the pressure, under the atmospheric pressure, and this is your cartridge of ink, okay, along with the nib, yes, and there is a small hole through which the cartridge is connected. Okay, that means the ink surface inside the cartridge or inside the nib and the ink surface outside the pen forms a system, and when you pull out the piston, okay, in ink pen in fountain, if you pull the piston outward, then pressure inside here decreases, but pressure outside remains the same. So there is imbalance of pressure, and less pressure is inside the cartridge. See, and to balance that pressure, the ink will flow into the cartridge. Okay, this is the same as we discussed for barometer. If you remember what we discussed here, yes, liquid always flows from high pressure to low pressure. Okay, here also atmospheric pressure is high, okay, but when you pull up piston, the pressure inside cartridge decreases, it will be in low pressure. Okay, and to balance that pressure, ink will flow inside the fountain pen, inside the cartridge. And a similar mechanism is used in filling syringes. Okay, syringes can be filled because of atmospheric pressure or working of water pump. Working of water pump and air pump. Do you play basketball or football? Or even if you ride bicycle, you might have used air pump. Okay, so water pump, air pump, syringes, fountain pen, they all work due to atmospheric pressure. Okay, if you have any confusion, we are discussing only this much for today. Tomorrow we will discuss about density and relative density, and the cases of regarding to floating and sinking, and then we'll do numerical. And for today, this much. For today, you have already got the work. Okay, this is your question. This is your question. Okay, when we ascend to high altitude, we feel headache, vomiting / nausea, nose bleeding, or diarrhea, etc. Why? If you did not get it, rewind the video. Okay, listen to it how many times you need to, and then give your answer. Okay, this much for today. Thank you, class.